Funny. Retrieval Augmented Generation, popularly known as RAG, is something that we've all become super familiar with over the last 2 years since ChatGPT came out. But did you know that RAG, the term RAG and the concept existed even before ChatGPT infused Gen AI into all our conversations? The person who created RAG or co-created RAG and wrote the first research paper is with us today. He's our guest for the It Depends podcast. I am so delighted to welcome Douwe Kiela. He is now CEO of Contextual AI to this episode. Douwe, thank you for joining.
Thanks for having me, Sanjeev. Looking forward to having this conversation.
I'm a firm believer that when you understand the history of how something happened, you have a much better appreciation of why you're trying to do something. So I see in our world, we spend so much time staying super high level and talk about drag and mixture of experts and this concept and that, but we never go deep into it. So I'm hoping today you can, give us a perspective on how RAG was created, how it's being used. So that's the conversation we'll have today.
Yeah, nice. Looking forward to it.
Excellent. So let's get started. Let's start with an introduction. Do you want to give us a bit of your history, your background?
Sure. I'm Douwe Kiela. That's how I usually tell people to pronounce my name, as in Dow Jones. So it's a Dutch name originally. Started this company 2 years ago now. And we really started it because we could see a lot of excitement around Gen AI, followed by a lot of frustration around it not really working. So hallucinations and how do I get it to work on my data and these types of questions, where I think we're honestly still trying to figure out the answer to a lot of those questions that we suffered from in the beginning of the Gen AI revolution. So my story is originally my background is in AI research. I did my PhD in NLP, natural language processing, in Cambridge in the UK, and joined FAIR, Facebook AI Research, very early on when it was still a very dynamic environment. There was a lot of freedom, and we could do whatever we wanted. And so one of the things that I was interested in for my PhD was this concept of grounding. So
Hmm.
how can I understand language in a machine with respect to some underlying ground truth, right? So in my thesis, it was mostly about perception, actually. So if you want to understand the meaning of the word cat very, very well, then you should watch lots of videos of cats. You shouldn't go and like read in a dictionary what the definition is of a cat, right? That doesn't really get to the real meaning. Um, so then when I got to FAIR, I was thinking about maybe grounding language or language
Hmm.
models. So this is before we actually had the term language model. So this was a sequence to sequence encoder decoder model. We figured, can we try to ground that in some underlying ground truth? And so an obvious ground truth for something like that would be Wikipedia, where you could say, okay, like everything on Wikipedia we consider to be true. The language model has to work on top of that ground truth. And if we swap out a different version of Wikipedia, then the language model needs to adhere to whatever is the ground truth according to that version of Wikipedia. So when we started this project, we were very lucky that a lot of the pieces for this were in place. So there was a very good sequence to sequence model. So it was generative. So this was called BART. So it was BERT, but then with a generative component. There was already a vector database. So we didn't call it a vector database at the time, but FACE, which still is the foundation for, I think, every vector database out there. That had just been made. And so it just made a lot of sense to use encoders to get embeddings, use FACE, the vector database, to do some retrieval, take the results of these Wikipedia chunks and give them to a generative model. And now suddenly you could do open domain question answering much better than you could do before. So this was the new state of the art. And so this paper came out. There were lots of papers around the same time coming out. So Google had a really good one called Realm. And so this was by no means the only one, but it was the first one to use a generative model for doing this type of stuff. And so when the Gen AI revolution really started and people needed a way to get those models to work on their data, then everybody realized, oh, actually, this is what the RAG paper was originally doing. So that's why that became synonymous with vector databases and language models and making Gen AI work on your data.
So Dow is very interesting. A couple of years ago, I decided to write one of my blogs on evaluating vector databases. And so I was doing my research. I actually discovered accidentally that the term RAG existed before ChatGPT, and I wrote it in my document. And I was like, wait, this term already existed? I just thought this is a new creation. I had no idea that a year and a half later you would be on this podcast and you'd be actually walking us through what transpired and how RAG came into existence.
But ChatGPT was also, it was not the first language model, and it was definitely not the first generative model for language, right?
Mhm.
So there's a long history that goes back even before transformers. So a lot of the key building blocks when I was doing my PhD, they were
Mhm.
already there. So auto-regressive decoding, so basically predicting word by word. We just didn't have a transformer, but we had RNNs, and then we had attention, and then at some
And
point we had
GANs.
and GANs, exactly. So yeah, a lot of the parts were already there. ChatGPT just made it suddenly available to the masses in a way where it was easy to consume.
Yeah, yeah. In fact, I just yesterday I saw OpenAI introduce something new for RAG, like one button, right? That just came out like a day or two ago, or something. But anyway, we are. I'm jumping ahead. So I
Mhm.
want before we go and talk about RAG more, what is the industry adoption of RAG today? How has the usage of RAG been from what you have seen?
I honestly think that almost every single enterprise deployment we see of
Mhm.
Gen AI has some RAG component.
Hmm.
I think there are a couple of exceptions where it's more sort of content generation problem. So there you just have a language model. You don't need to contextualize that language model in the right way. But for almost everything else where you want that technology to work on your data, you need some form of RAG to make sense of it. Yeah, it's really everywhere. It's when we started the company 2 years ago, we still had to explain sometimes what RAG
Hmm.
was. And now when I give a talk somewhere, then if I go like, do I have to explain what RAG is? Then people think that I'm asking a silly question.
Yeah.
So that's good, I guess.
So the company that you created is called Contextual AI, right? And what is the like? What's your North Star? Like, what does Contextual AI do?
Yeah, so we are a platform for building enterprise RAG agents. So obviously this is the year of agents, right?
Hmm.
But these agents need to work on your data, and that's
Yeah.
why they still need RAG. And with our platform, you can make that very easy. So you can create these agents in a matter of minutes. And each of these agents, because of our underlying technology, or what we call RAG 2.0, will outperform any vanilla sort of standard RAG implementation that you could have built yourself, because all of our components are state of the art and they are trained to work together. So because of that, you get this very performant RAG agent very quickly, and then you can specialize and
Hmm.
customize that for your use case. So as a long-term mission, what we're trying to do is deliver ROI for AI. And specifically, we want to do that by going after the more difficult problems. Right? So there are a lot of companies now that you can use, and they can probably help you with simple questions like who is our 401k provider? But that's not really where you get the ROI from AI
Yeah.
of AI from, right? So you want to solve really hard problems, and if you want to solve them well enough to be productionized, then you need to really specialize for that use case. And so that's what we're focused on is solving very hard problems in a way where they can be productionized and you get value from that deployment.
I'm very curious to hear about some real life use cases. When I saw you a few days ago at the Gartner Data and Analytics Summit in Orlando, and I stopped by at your booth, I picked up a piece of collateral from your booth. There were some companies mentioned, one of them was Qualcomm. So it would really help the viewers visualize how your platform is being used. What do we mean by AI or AI agents or RAG agent? Are you okay? Can you talk about Qualcomm as an
Yeah,
example?
yeah, for sure. That's really an example that I'm very proud of.
Ah, okay.
This was a lot of work,
Hmm.
but a very important problem, and we were able to solve it really well, I think. So the case study is also on our website, so I can talk about it. So Qualcomm had this problem with their customer engineers
Hmm.
that they were oversubscribed, basically, and so they have a lot of customer engineers. They are all very highly educated, highly specialized. They have master's degrees or PhDs in electrical engineering or related fields. Hiring people like that is very difficult.
Hmm.
And in general, you want to make these people very efficient because they are important people, right? So how can we enable them using Gen AI to focus on the work that is the most valuable for the company. And when they get a question that maybe the answer is already documented for somewhere in their knowledge bases, that AI can answer that question so that the customer engineer can focus on more valuable problems. So that's the problem we set out to solve. Was very difficult and because maybe you can get this to work on 10 PDFs, but if you have to get this to work on a million PDFs,
Hmm.
then it becomes a very difficult and very different problem. And this is very domain-specific data. Language models often have not seen any of this data before, so they really struggle. And then it's multimodal data. There's tables, there's circuit diagrams, there's all kinds of difficulties in those documents. So we have solved all of those problems, and we now have a customer engineering assistant, essentially, that helps answer a lot of these questions that are highly technical. So when I see the question, I don't know what the question means. When I see the answer, I really have no idea what the answer means, but the system does an amazing job at answering these very, very technical questions. And so we're adding a lot of value to Qualcomm because now their engineers are much more efficient and making engineers very efficient. That's really the holy grail, I think, for a lot of Gen AI applications.
Approximately how many users are there for this customer engineering agent?
Yeah, so we are their only Gen AI deployment at scale
I
in the
see.
entire company. And so this is thousands of customer engineers.
So thousands of them. I'm curious, how do they access the agent? Is it standalone or is it integrated? What application? How do they interact
Yeah,
with it?
so that's very important. I mean, obviously, I can't give very specific details,
Hmm.
but one of the really important ways to make sure that a Gen AI deployment is successful is to
Hmm.
integrate it into existing workflows.
Hmm.
So that's what we did. They already had their own system for keeping track of a lot of these things, and we made sure that we can integrate with that through our APIs so that they can just have it in their workflow and benefit from it directly without needing to change how they work. Because if you require a real change in how they do their jobs, then the change management is going to be
Yeah.
very difficult as well.
So it's integrated into the workflow. And does it, what systems can you mention, maybe one or two that it integrates with in the back end?
I I can't tell you the exact
I see.
system. I don't think they would
Okay.
like it if I did
No,
that.
no worries. So for RAG to become RAG as a technology is pervasive, but for it to become a category, I come from former my life as a Gartner analyst. So we would create market guides or magic quadrants. Because there's got to be, some sort of like some number of companies in a category. So I'm just curious, without getting into any competitive issues, are there other companies that are doing things similar to what you are doing?
Yeah, I think there are a few, not exactly the same as what we're doing, but there are companies operating, I think, in adjacent areas. So a good example is Glean,
Mm.
where they do enterprise search, internal search.
Mhm.
I think they're very focused on integrations, and it's very general purpose. We are much more focused on high value use cases and much more specialized. There are companies like Cohere where my friend and colleague Patrick Lewis, the first author on the RAG paper, he works there. So they
Ah,
also do a lot of work in RAG and in enterprise. And then, yeah, obviously, I think you mentioned it, OpenAI and Anthropic are also looking at this, but they're really focused on the generative part, and we're
yeah.
more focused on the contextualization part,
Hmm.
hence the name of the company,
Ah.
Contextual AI. We are all about providing language models with the right context to be able to do their job. But I definitely think that RAG, or maybe this problem of providing context for language models, that needs to be its own market category. That's a very different problem. It's really a systems problem. It's not a modeling problem that you need to solve there. And if you don't solve that correctly, then you are not going to be able to benefit from Gen AI technology.
So interestingly, you said you talked about language models. When we were at the Gartner Summit, I saw some news that you had launched a grounded language model or GLM. What is a GLM, and and how do you see yourself? Do you see yourself more in the language in the model space or the agent or application space?
Yeah, I think we are in a platform space, if that
Platform.
is also an option. So
Yes.
the GLM is really, as I said, right, it's really about systems. So models, especially a language model, is
Hmm.
only 10-20% of this much bigger system that has to solve the problem. And one of the problems we ran into when we were setting out to build these state-of-the-art RAG systems is that language models themselves are kind of designed to hallucinate in a way,
Hmm.
right? So that same general purpose language model that you want to use for your RAG problem, that is also useful for your creative writing department in marketing, right? And so those are very different use cases, and you should use different language models for that, honestly, right? So we took Llama in this case, but it could be
Hmm.
any sort of open source language model, and we trained it uh, uh, substantially on our own data to make sure that it becomes much more
Hmm.
grounded. So it's currently number one on the factuality facts leaderboard that measures how factual language models are. And what that means is it only looks at the context and nothing else. So it does not
Hmm.
rely on its own internal knowledge. So it might know a lot of stuff about, I don't know, Bitcoin or something like that, right? There's a lot of Bitcoin training data on the internet. But if there's nothing in the context about Bitcoin, then it's not going to talk about it. And so that's what you want if you're in an enterprise setting, right? So maybe not in the, so it's terrible for creative writing, to be clear, but it's the best in the world for RAG, right? You want to specialize for those types of use cases and make sure that you don't do anything that you're not supposed to.
I'm wondering, you can train an open source model like Llama 3 and create a contextually rich model grounded language model. As we get into cases where we are using companies may have tens, hundreds, maybe even thousand agents. One is doing PDF extraction and is using Gemini. Another one is doing coding and is using Claude Sonnet 3.7. Another one could be doing reasoning and using DeepSeek. So we may have all of these models. How are we going to have a grounded version of all of these? Because some are open source, some are not.
Yeah, so I don't think that they all will be grounded. I also don't think
Hmm.
they all have to be grounded. If you have a creative writing agent,
Hmm.
they will not be grounded, right? But I think it's a good point. I think, and that's why we have this platform for building RAG agents. Is
Hmm.
I think most useful agents for an enterprise need to be grounded in something.
Hmm.
Ideally, so it could
Yep.
be in their code base or in their knowledge base or what have you, right? So, yeah, I think the most valuable agents will be RAG agents. And so that's why we're
Hmm.
focused on that. And then your question is also about like how do these agents then work together?
Correct.
I
Yeah.
think there's a lot of work, very interesting work being done on kind of multi-agent communication protocols and things like that, which is fun for me to see. I used to work on multi-agent emergent communication before we had language models again,
Yeah.
where we were trying to do that
Right.
in a grounded way, actually. So we have
Right.
a couple of papers in like
Yeah.
2015, 16 on sort of multi-agent neural networks trying to communicate in a grounded environment.
Yeah, yeah. So I'm digressing again because I want to come back to what you had said a few minutes ago. But since we are talking about agent-to-agent communication, it's something that is also getting a lot of airtime these days. It's like every few days we have a new buzzword, something we hone into, and then a few days later we move on. So right now, as we are recording this, it's Anthropic Model Context Protocol, MCP, which is not agent to agent, it's more like model to external sources. But I've already had some people ask me, how is RAG going to get affected by the rise of Model Context Protocol, MCP? Any thoughts?
I think MCP is just a way to standardize the retrieval part. So you are
Hmm.
still augmenting the model context
Hmm.
using retrieval is just according to one protocol. So I think there's a lot of confusion, I think, with people who don't really understand what is really happening there.
Yeah.
So you can have a vector database and then have an API on top of that, and then have MCP call that API.
Hmm.
Are you then using retrieval to augment the generator? I think so, right? So,
Yeah.
yeah, I think there's a lot of interesting work happening there, where retrieval essentially is just one of the ways that you can augment language models,
Yeah.
right? So it happens to be probably the most valuable, useful way, but there's all kinds of different things you
Right.
can do. So yeah, maybe we need to drop the R at some point and just call them augmented language models or augmented generation.
Oh, wow.
So you
Right.
can do vision augmented
Right.
generation, for example.
Yeah.
But yeah, you need to augment those models
Right.
with something.
So to summarize this discussion, and then we'll get back to our questions, is that MCP and RAG are orthogonal concepts. MCP is a transport protocol, it's like an API, and RAG is what you do. RAG can use MCP or any other protocol for that matter. If tomorrow OpenAI has something different, then so be it.
So
So
you
so
can
there's
use
no
MCP to do RAG, or you can do RAG without
without
MCP.
MCP.
Yeah,
Yeah,
it doesn't really matter all that much, I
right.
think. Yeah.
So Dow,
So what's interesting, actually,
yep.
maybe a deeper point, is
Mhm.
like a lot of people when they don't really understand it, they try to sort of simplify it in their minds in sort of dichotomies.
Hmm.
And so it's like it's either RAG or fine tuning, right? That used to
Hmm.
be one of the things, but that's
Hmm.
not true, right? If you want to get the most performance out of it, everybody, if you're really working at the frontier, knows you need to fine tune your RAG system. So you need both. And then
Hmm.
people said, oh, yeah, so it's like RAG versus long context. Like now that we have long
Hmm.
context models, we don't need RAG anymore. So, well, guess what? Those long context models, they don't really work all that well. So even if they
Hmm.
advertise 2 million tokens, after about 2,000 tokens, they start degrading in performance very rapidly. And still, what you want to do when you have something like RAG is find the most useful pieces of information, put them into context, because otherwise you are paying for processing things that you don't need, right? So if I want to answer a very basic question about whatever Harry Potter or something, I don't have to read the whole book to answer that one question,
Yeah.
right? That's very wasteful. So again, that's a false dichotomy. Ideally, you have a long context model, and then you can find the right pieces of information to put in that context and sort of think about the cost quality trade-off there using RAG. So you want to do RAG and fine tuning and long context with or without MCP, with or without tool use, all of it. And so that yeah, the real world is more nuanced and doesn't have these types of dichotomies.
So I had an interesting thought that crossed my mind. So let's say I want to do a natural language query, and I want to find out. My prompt is that tell me what should be my next best action or a engagement plan for my customers that are about to churn, and in my customer table, I've got my customer tweets that are coming in. So I have their sentiment idea. I know what they've bought in the past. I know the volume. So I'm doing this kind of like query from to LLM, but I need to retrieve the customer information from this
Mhm.
table that's constantly changing. So how does RAG help me with real time? And so the real-time tweets are coming in, but they need to be embedded. Do I need a separate vector database like Pinecone, or can I do it in my operational database? So I'm just trying to understand how can I do RAG on data that's as fresh can be, and get some amazing uh, outcomes from a
Yeah.
LM.
Yeah, so I mean that's what RAG is for, right? For
Yeah,
making sure that you're always up to date on the freshest information. And
right.
so I guess the problem you're describing is a combination of unstructured and structured data. So
Yes, correct.
another false dichotomy there is that a lot of people think that RAG is really only about vector databases
Hmm,
and embeddings. I would say you can also run a SQL query as a
hmm,
retrieval step and then get the results of that, right? So what we do in our platform, in
hmm,
Contextual's platform, is a combination of structured retrieval, unstructured retrieval, API retrieval, so all different types of retrieval modalities that you can use. And then you want to reason over the outcomes of that, or you even want to reason over the strategy that you're using to do that retrieval, right? So it becomes very agentic then, like you were saying, like I need to formulate a plan, but
hmm,
maybe I need to go and look at their sentiment first, right? So let
correct.
me find the most relevant tweets that they had that are about us, and then look at the sentiment, and then maybe based on the sentiment, do some more retrieval in a database. Like, let's look at what
Hmm,
they bought. And then it's like, oh, actually, like maybe there was some like violation of a policy that they really didn't like. Let me check the policy document or like the contract that we had with them. And so all of these different types of data that this agent needs to consume, yeah, they need to be hooked up to your system in one platform, and then you can do all that reasoning. So that's very much where we're headed now, and that's really exciting, I think, because that's transformative for a business, right? That you really get
hmm.
differentiated value from that capability.
So it's like a multi-step. So it's an agent with multiple steps, right? So first
Yeah.
go get sentiments, then go look at the history, then look at other things, and then finally, so every step we're doing
Mhm.
RAG. And
Yeah. But
so
so we
when,
don't even necessarily have to do RAG every step, right? So this is really the paradigm of test time compute and reasoning and
yes,
agents, right?
correct.
So it's we
Yep.
formulate a plan, we execute on the plan. Maybe something goes
Hmm,
wrong and we need to revise the plan, or we need to try
hmm,
again, or
hmm.
maybe we need to run some calculations in between, right?
Yeah.
So there's all kinds of things that you can do during test time compute, but RAG is one of the most important things that you can do if you want this agent to work on your data.
You've talked about RAG 2.0 a few minutes ago. How is that different from standard RAG?
Yeah, so the way we do RAG 2.0 is all of the components are individually state of the art for us.
Okay.
So as I said, we have our grounded language model
Yep.
that's state of the art. We have a state of the art retrieval pipeline and re-ranker.
Hmm.
That re-ranker has the ability to follow instructions, which
Hmm.
is very important because then you can tell it how it needs to prioritize your enterprise data, right? So maybe even depending on the query, you have different priorities. Sometimes you care about recency, sometimes you care about who authored the document, or about
Hmm.
the document type, or all kinds of different constraints that you might have. And then we have a state-of-the-art extraction pipeline as well, and a state-of-the-art text-to-SQL model as well. Lots of state-of-the-arts. So all of these different parts are very good, and then they have been trained on the same underlying data
Hmm.
distribution. And because of that, they have learned to work together much better than if you had disparate, kind of separate components. And that's why we're so much better out of the box than standard
That's great.
Frankenstein RAG.
This is fascinating, by the way. I'm going in like so many different tangents because there's so much to talk about that I want to come back to when you were talking about GLM. You mentioned something about facts benchmark number. What is facts? What is this benchmark?
So it's a benchmark that measures how factual your language model is. So factual in the sense that you adhere to the context that was given.
Hmm.
Um, this could be counterfactuals even, right? So you say
Hmm.
like something is true that is not actually the case, or maybe it will be the case in the future or was in the past. So based on that context, you need to generate the right response. And so when Gemini 2.0 came out, for example, they made a lot of noise about it being the most factual language model.
Hmm.
But it turns out that our language model is much more factual than Gemini 2.0. And so I think that's really because we focus on RAG and we want to be the best in the world at RAG. We don't want to have the best general purpose language model in the world.
Is there a Hugging Face leaderboard which has your grounded language model and a benchmark with your facts number?
Yeah, I don't know if they're on Hugging Face, but you can just Google the facts leaderboard
Okay,
and then you can see it. And so there's yeah, the leaderboards for the things that we're good at, they're all just open leaderboards. Yeah.
got it. There is also this notion in the market that because of hallucinations, if you want to improve your accuracy, then you should have a semantic model or ontology and put graph rag on top. Just curious, what are your thoughts about graph rag, and do you do it, or is it orthogonal to what you do?
Yeah, so it's one of the retrieval modalities we support.
I see.
Right. So as I said, we have this agent kind of formulate a plan. We call it mixture of retrievers. And so one of the
Hmm.
things that it can do is search over a graph. Um, I honestly haven't seen a lot of cases where it really matters
Hmm.
having that. And I think if you look at the original graph rag implementation from let's say Microsoft, I think it was. It's actually a data augmentation technique. So you don't necessarily need to have a actual like graph representation. What they often do is they just look at the entities that exist in documents, get their relationships, so extract a bunch of information from these documents, and then put that into the vector database as separate rows that you can now retrieve. And so a lot of the kind of hierarchy that exists in documents or between entities and things like that then becomes independently retrievable in a vector database. So it's a nice technique. It's a data augmentation technique. It doesn't actually have all that much to do with graphs necessarily. It's just a graph is a very abstract concept. So anything is a graph really. And I think what is interesting is if you look at things like Neo4j and like actual like graph databases where that is the right representation format for a particular data source that you have. So in that case, if you're actually like working on top of, let's say, social networks or something like that, right? And it has to be represented in a graph anyway, then you want to do something like graph rag. But the way you would do that is you generate in their query language, you would actually generate queries,
Mhm.
just like with text to SQL, but now it's just a different query language, and then get those results and use that.
Got it. Yeah, very nice. Thank you. Irrespective of whether it's GraphRag or it's grounded language model, the foundational truth is that if organization's data is not of high quality, then all bets are off. Or
No, not all bad. So I think that so I mean you can never be better than your data,
correct.
right? But if you have very bad noisy data,
Hmm.
you can still make sense of it if you have things like our re-ranker, right? So
Hmm.
there will be a lot
Interesting.
of noise coming from your kind of first stage retriever,
Yeah.
but you can cascade retrieval steps and make the model better and better at removing that noise, and then you're
Hmm.
still left with the needle in the haystack, right? Or the needles in the haystack that you need to solve your problem. So it's doable. I sometimes hear people say like you need to clean up your data, otherwise it doesn't work. And that frustrates me because AI should work even if you
Hmm.
have noisy data. right? It's like in the real world,
Yeah.
you just don't have this luxury of creating
Yeah.
clean data, and the people who are uh, selling you on that are kind of consultants making a lot of money from cleaning up your data, and then you can do continuous data cleaning projects for the rest of your company's existence. Ideally, you just get AI that works on top of your data without cleaning, and so that's what we're trying to aim for.
By the way, I love this answer. This is, you finally close a loop for me. The first video I did for a friend of mine at the Gartner Summit, in that I said the whole notion was like, without data governance, AI will fail. It already hallucinates. And I was like, okay, we need to stop here, because if we're going to spend all our cycles doing data governance, our competition is going to be running away with Gen AI. And
Hmm.
if we failed at doing something for last 20, 30 years, and we think magically we'll be able to be successful so we can do AI, it's not going to happen. But what you are saying is music to my ears, because you're saying that by re-ranking and using some of these intelligent techniques, you can make sense of your data. So it's important to recognize that don't slow down your Gen AI experimentation, because the market pressures are there and you don't want to be left behind. So don't make data governance as a showstopper
Hmm.
before you can do anything in Gen AI, because then you
Yeah,
won't go anywhere.
exactly. Like that is so in an ideal, so data governance, there are certain aspects of that that are really important, right?
Hmm.
But they're
Yes,
mostly, I
hugely
think,
important.
around sort of
Yeah,
ethical or regulatory pressures or things like
correct.
that.
Yeah,
You should not have to worry about data governance because otherwise your AI doesn't work.
yeah,
That just means that you have bad AI.
yeah. So, since we're talking about data governance and data, one of the big confusions I see in the market is, who is the persona that we are targeting our product to? Because we've got technical roles like data engineers, data scientists, AI engineers now. Then we've got business people who are more interested in the usage of that data. So, compliance is one of their big concerns. When you go to market, who are you talking to? What personas are interested in contextual AI?
Yeah, but both those roles you mentioned. For me personally, I just really love talking to people with real business problems. It's like I have,
Yeah.
lots of people doing the same thing. Like, how can I make them not have to do that same thing over and over again and really just solve it once and for all and then save myself a lot of money and make my people much more efficient and productive. Or even just like there's this thing that would be great if we could do it. And if we do it, then we're adding so much revenue to the company, or we have this massive unlock for our customers. So those are the ones that I personally get the
Mm,
most excited by. And then obviously when we talk to those folks, they also have their own internal AI teams who have been looking at a lot of the same problems that we are solving. And so sometimes they already have even like basic RAG platforms
mm,
and things like that. And they're starting to come to the understanding that building this RAG platform and then keeping it up to date with all the latest innovations and constantly having to worry for every single problem that they're solving for their line of business. Now they need to optimize the chunking strategy again, and they
mm,
need to like find the optimal like hybrid search parameter and things like that. But that is not a good use of their time, right? So we're also seeing a lot more interest now in the what I call the platform buyers, basically. So AI leaders who are thinking like maybe I can step up one level in the hierarchy. I don't have to do RAG anymore. I just have to make sure that I can use RAG to solve my business problems for my business counterparts. So that's kind of a process that's happening right now.
I see. So for these business people, what are their key priorities, focus areas? And for technical people, from technical point of view, what are some emerging trends that you're seeing? I'm just curious, has LLM become a commodity? GPUs become a commodity? Where is the puck going to?
Yeah, so for business buyers, I think they really care about something we already talked about, which is how can you integrate into existing workflows and
Yeah,
make people better, right? And so it could be more
correct.
efficient, more productive, better at something
Yeah.
else, or maybe something that is more directly customer facing.
Mhm.
So they care about making money. in the end.
Yeah.
Yeah, so I think we're getting to the point now where the technology is good enough where you can really articulate that value quite crisply, right? It's like we can save you tens of millions of dollars if you don't have to hire that many highly educated customer engineers, for example, right?
Mhm.
Yeah, that line of business cares about integrations, efficiency, user experience.
Mm.
You know, maybe one of the biggest problem they actually care about also is the inaccuracies. So it's
Mm.
not about how good you are, it's about what you do for the parts where you might be wrong, right? How do you mitigate that risk? Especially we work with a lot of kind of financial services regulated sectors, and so there you need to have a very good story for what you do when you have 99% accuracy, but you still have 1% where it might be wrong. So you need to check for groundedness separately. You need to have audit trails for regulators. You need to have humans in the loop. You need to have very accurate attributions. Like all of these things are
Yeah.
built into our product for business users. And then on the technical side, where the puck is going, it's obviously agents.
Mm.
I think your observation is right that language models are becoming a commodity. I think the language model companies that are incumbent right now, they are going to need to move up the stack a little
Mm.
bit, I think, to justify the valuations that they have, because things like DeepSeek have shown that actually their moat is not that big. You can reproduce this yourself if you have a limited amount of synthetic data, and maybe you like hand annotate it with real humans to make it better. And then if you have that good starting point, then you can train very good language models very quickly. Um, so I think the interesting problems that seemed kind of out of reach maybe a year or two ago around sort of multimodality, the intersection of structured and unstructured data, having virtually no hallucination, like all of those things are happening essentially now and coming together to add a lot of business value, especially when you combine that with test time reasoning and agents, then you can do amazing things to really add a lot of value.
That is great. So I have one last technical question then because we're getting to the end, but I hear a lot about DPO. Uh, and something, can you explain what does DPO stand for and how does it come DPO, KTO, RLHF, any thoughts on that?
Nice. Yeah. So ROHF was really the secret sauce for ChatGPT, right? It was so ChatGPT was trained in three stages. It was pre-training the model, then instruction, fine-tuning it on instruction data, so that it's basically better at following prompts,
Hmm.
and then ROHF, which captured human preferences. And so a preference was literally this one is better than this one if I have two answers, or like if I have 10 answers, like this one is better than this one is better than this one, right? Some sort of ranking. So that was used for training ChatGPT and a lot of those early models. But then people realized that training these reward models, so the model that actually needs to capture those preferences, that's very expensive. You need to have this paired data, which is annoying. So first DPO, direct preference optimization, came about, where, as the name suggests, it's optimizing directly on the preferences, so there is no reward model. And then with KTO, so that was done at Contextual, it stands for Kahneman-Tversky optimization. We're looking at these preferences because when you get feedback in a system and somebody gives you a thumbs down, ideally you don't want to have to go and collect what the thumbs up would have looked like, or vice versa, right? If you have a good answer, you don't want to go and like turn it into a couple of bad ones just so that you have training data for DPO. So that's why we worked on KTO. And that turned out to work really well. And even if you had these paired data sets, so the original ones that were used for training on with DPO, you probably actually still want to do KTO on them just because of how it optimizes. One of the advantages is that these techniques are very sample efficient, which means that you need relatively
Hmm.
few feedback examples to make a dent in the performance of your system. So I think there's a lot of still very underexplored stuff around this preference optimization with or without RL, right? RL is just kind of a way that you get gradients flowing into these systems from something that is not differentiable, I guess. That's what you use RL for. So yeah, there's a lot of interesting stuff to still do there.
This is a fascinating discussion. So we are close to the end. So I want to pivot to your change from being the co-creator and writing research papers to being the CEO. What are some milestones you're most proud of since starting contextual AI?
Ah, yeah, so for me, it's been a very natural transition,
Ah,
I think.
okay.
And so maybe this sounds a bit weird, but I actually think that being a research scientist and a CEO founder are actually quite similar.
Oh, wow. Okay.
So in there, I had a lot of freedom to set my own research agenda,
Hmm.
just like I have now, right? And so obviously you have to choose that research direction based on what you think everybody cares about or what you think the most interesting, valuable, groundbreaking problems are to solve. And then if you want to be really good at being a research scientist, you need to also communicate about it very well and you know, write papers and give talks and talk to your colleagues and things like that. So I actually think that a lot of the traits
Hmm.
of being a very good research scientist translate very directly to
Oh,
being
wow.
a good founder CEO.
How interesting. I would have never thought of that. Although I see your point. I tell anybody who will listen to me how important it is to write. Because when you write, you really understand the topic better than before.
Yeah.
So, do you have any advice for listeners who are looking to build their career, follow your footsteps?
Um, yeah, my favorite advice to give people is always stay uncomfortable.
Ah,
So if you are comfortable, then you are not learning. Right.
yes.
And so this is actually is part of the reason why I started this company.
Oh, wow.
Obviously, this is a very uncomfortable experience for me.
Yes.
Right. I have a lot of new things to learn. There's a lot of pressure. But yeah, this is a kind of a lifelong learning approach to life, I think, where it's just if you can constantly keep yourself uncomfortable, then you have the most interesting, most valuable experiences, I think. So if you are feeling comfortable, make yourself uncomfortable.
Hmm. Yeah, I said this on my previous podcast. When my kids graduated from college, I wished them a life of discomfort because being in comfort zone is like posting. So,
Exactly.
because I do the same thing too. Sometimes overcommit and push myself, but then, amazing things happen.
Yeah.
One final question. I would love to hear what are some of your hobbies and passions outside maybe the world of tech. Tell us something that the rest of the world doesn't know about you.
Well, I wish I had time for hobbies, honestly. Like being in tech. So with my job, it's very hard to have time for anything. So I would say my favorite hobby right now is my kids.
I see.
So I have two kids, a 1-year-old and a 6-year-old,
Oh my
and
God. Wow.
they are uh, they really put your life in perspective, I think that so everything else feels not as important as your kids. So kids are great for imposing that sort of relative understanding of priorities.
Thank you.
Other than that, yeah, if you're in the Bay Area, you might see me going around on my bicycle in the mountains because that's the only way that I can not work because I have to pay
Yeah,
attention to not crashing on a bike.
you're right. I know you travel quite a bit because I saw you 2 weeks ago, and now you're going to the AI Summit in Boston in a few days.
Yeah, so
Oh
I'll
no,
be
in
at
April.
the AI Summit in Boston. Before that, I'll be in Vegas for Google Next, and before that, I
Ah,
will be in New York for a conference. And I saw you in Orlando. I was in
yes.
Vegas last week as well. So yeah, spending a lot of
Human
time
X, right? You were at
at
Human
UMass.
X.
That's
I
right.
see.
Yeah,
I will see you at Google Cloud next. I'll be there. So
see you there.
great. Thank you so much for taking the time with your company, your kids, your travel. You still managed to carve out this time. I know it was very hard for you to do this, but I genuinely thank you for coming to this
Thank
podcast.
you. This was
Thank
fun.
you.
Thank you.
Thanks, everyone. Until next time, stay tuned and we will talk soon. Bye.